Okay, so Gaussian elimination, what actually is it? Well, you may remember Gaussian eliminations from videos such as the last one, and it is the method of solving a system of equations by expressing them in an augmented matrix. Reducing it to upper triangular form and solving it by back substitution. And this is called Gaussian elimination. Okay, so first thing we're going to try and do is we're going to try and explore solving something like this. So we are going to solve a plus b plus c equals 2 if 4a plus 2b plus c is equal to 4 and a minus b plus c is also equal to 4. So hopefully there's a couple of things we notice here. Hopefully we're spotting that now we've got three variables, a, b and c, but also that we've got a third equation. Okay, and that is essentially how it works. Okay, you need to have the same number of equations for the number of unknowns that you have. So before we looked at simultaneous linear equations, so there were two variables there, we had our x and y's, we needed two equations to solve it. Here we've got three variables, so we need three equations. If we were to have a, b, c, d, I would need a fourth equation underneath before I would be able to pick out exact values for these. So, first thing I'm going to do is I'm going to put this into a matrix. And so again, all I'm looking to do is take the coefficients. So I've got 1a, 1b, 1c, that gives me 2. Next line I've got 4a, 2b's and 1c, that gives me 4. Third line I've got 1a, minus 1b, 1c, and that gives me 4 also. And so augment my matrix, put brackets around it, and there we go. Okay, if we don't put brackets around it, it's not a matrix. Okay, it's a little thing, but people, for whatever reason, seem to decide they don't want to put them in. You need to put your brackets in, and you need to include some way of picking apart your two sides. Okay, we use this way. I know other people that keep them as two separate matrices, that's fine. Okay, but you need to have a way of doing it. So what we're going to do now is we're going to keep the first row the way that it is, and I'm going to perform some row operations so that we can have these things here underneath the 1 turn to a 0. Because remember, what I want is I want to have a matrix that is in this upper triangular form. So I'll have some numbers there, and I want to have it so that in this shape are where my numbers are, and these are just zeros. And what I want to be able to do is I want to have it so that my bottom line, there is just a thing, right? Whatever goes there. And then for every line up, we can introduce one more element until we work all the way back up to the top. So that's the idea behind this upper triangular form. Okay, so I want to have this bottom equation, well, if it's just one unknown, that one with 2, that one can keep all 3. So we don't have any need to perform any kind of row operations on the first one. It can just stay 1, 1, 1, 2. Next thing I'm going to do is my row 2. So row 2 is going to become, well, it's going to be row 2 minus 4 lots of row 1. Okay, let's start to put these in so we don't lose our place. So, row 2 is 4, minus 4 lots of 1, 4 is 0. We get 2 minus 4 lots of 1 is minus 2. We've got 1 minus 4 lots of 1 is minus 3. And then I've got 4 minus 4 lots of 2 gives me minus 4. Underneath my row 3, now that's going to become row 3 minus row 1. And again, all we are looking at doing just now is we're looking at making it so these two things become zeros. We'll sort the rest of it out, but once we can get these two things to become 0, that is us quite far of the way toward getting our upper triangular form. So that's where they match up in terms of our equation. These two to these two. So row 3 minus row 1, so I've got 1 minus 1 is 0, minus 1 is minus 2, 1 minus 1 is 0, and then I've got 4 minus 2, and that just gives me 2. Now, depending on what kind of person we are, you know, we can pick apart different things and how we want them to be, what order we want them to be. We could argue at this point here, we could start to solve them, okay, but it's not necessarily in the upper triangular form that we were hoping for. So what we're going to do is we're going to keep doing it so that we can get it in that form, just so that we can see what it's like, alright? But I do appreciate that some of you are already starting to work backwards from there and figure it out. The conditions are just now that you have 1 of them there, 2 of them there, and 3 of them there. It just happens that we've managed to find it in one easy step. When you come to do these, you will be required to do another step. So I'm going to show you it so that you can hopefully manage it yourselves when the numbers are a little bit more complicated. So what we're going to do is, first one stays the same, 1, 1, 1, 2. Next one, it can stay the same because it's got only 2 things in it now. And I want to do something with my third one so that this element here where the minus 2 is becomes a 0. And so what we're going to do is we're going to subtract them. So row 3 is going to become row 3 minus row 2. So 0 minus 0 is 0, minus 2 minus minus 2 is plus 2, so it becomes 0. 0 minus minus 3 is 3. And then 2 minus minus 4 is 6. Okay, so again, he grants you the changing of the matrix. It makes very little difference to your end answer in the way as you go about it. But what we were looking for, and hopefully what we can see we've got now, is we've got this kind of set of zeros down my bottom left, and I've got the rest of my numbers here in this main part in this upper triangular form. Okay, and that's the thing that we're looking for. So what I can do from this is I can take that 3 lots of C is equal to 6. And so C then needs to just be 2. From that I've got minus 2 lots of B minus 3 lots of C is equal to minus 4. Substitute in what I know, minus 2B minus 3 lots of 2 is minus 4. And so we've got minus 2B minus 6 is equal to minus 4. Shift that about, we're going to get B equals minus 1. And then finally, taking my top line, I've got A plus B plus C is equal to 2. And so again, I've got A minus 1 plus 2 equals 2. A is equal to 1. And so we've got our 3 answers, C, B, A. Okay, that is all we are looking for you to do.